What if you tried to ignite a gas giant, like Jupiter, with a matchbox? Sounds like a wild idea, right? Well, let's explore this imaginative scenario and see what happens. Gas giants, like Jupiter and Saturn, are made primarily of hydrogen and helium. Jupiter, for example, is about 90% hydrogen and 10% helium by number of atoms, with trace amounts of other elements. Now, hydrogen is highly flammable, so it might seem like Jupiter is just a massive ball of potential fire waiting to be ignited. But there's a catch. To start a fire, we need three things: a fuel source, an oxidizer, and a heat source. We've got the fuel source hydrogen, but what about the oxidizer and heat source? On Earth, fires typically rely on oxygen as an oxidizer. But on Jupiter, oxygen is in short supply, making up less than 0.1% of the planet's atmosphere. So, we need to bring our own oxygen to get the party started. But what about our heat source, the matchbox? Here's where things get tricky. Lighting a match requires friction. In space, there's no atmosphere, and without air resistance, it would be extremely difficult to create enough friction to ignite a match. But let's say we somehow manage to light our match, perhaps by using a specialized matchbox designed for space. Now what? So, we've got our match lit, and we've brought our own oxygen. Now we're ready to ignite Jupiter. As we move the match toward the planet, the hydrogen in Jupiter's atmosphere starts to react with our supplied oxygen, creating a small fireball. But this fireball isn't like the ones we see on Earth. Due to the lack of gravity and atmospheric pressure in space, the fireball expands rapidly, and the flames behave differently, burning in spherical shapes. It's fascinating and terrifying at the same time. Now, here's the big question. Would this little fireball cause the entire planet to go up in flames? Unfortunately, or fortunately, depending on how you look at it, our fireball wouldn't create a massive, planet-wide inferno. The fire would need a constant supply of oxygen to continue burning, and since Jupiter's atmosphere lacks significant amounts of oxygen, the fire would eventually burn out, leaving the gas giant mostly unscathed. However, even a small fireball could have some interesting consequences. The heat generated by the fire could cause local turbulence, creating temporary storms or disturbances in the atmosphere. It might even create some spectacular auroras, as charged particles from the fire interact with Jupiter's magnetic field. So, what have we learned from our little thought experiment? Well, lighting a match on a gas giant like Jupiter isn't as simple as it might seem. Without the right conditions, even the most flammable materials won't burn. But this exercise has also given us a chance to explore the fascinating physics of fire in space and the unique properties of gas giants. So, the next time you strike a match, take a moment to appreciate the complex interplay of elements that make it all possible. And as always, thanks for watching.